we had a request to go over precipitation rate again. So precipitation rate is flow over area, and it's very important because we want to know everything is about having even precipitation rate, and that's why we strive for match precipitation rate, that we're putting down the same amount of water in an area. So each zone, all heads on a zone should be the same precip rate. And then if we have different precipitation rate equipment, like rotors versus spray heads versus drip, how we eventually make them match precipitation rate is we adjust the time. And then that's how we put down the same amount of water. And so what we're going to do in this scenario is do a little math. So the equation for precipitation rate is 96.25. It was brought up. Why do we use 96.3 in some instances? Is a lot of times in irrigation we're not as precise as these extra digits need. So oftentimes it's 96.3. So either way, it's acceptable in the industry. You're going to be close enough for irrigation. And then Q is the gallons per minute, your flow. And then A is your square footage of the zone that you're irrigating. So now to do the math is I'm going to take 96.25. I'm going to multiply that. Let's say I have a few heads in this zone that equals 2 gallons per minute. And then I'm going to divide this, and let's say my area that I'm in is a 10 by 10 landscape area. So that's 100 square feet. And that would give me 1.93 inches per hour as my precip rate. So that's a little more than a spray head. And so that's the math that we would do. So we can calculate a precip rate off of just knowing the total flow for an area and the total square footage for an area. And then we will move on to the next example. Now I had another question of how do quarters have so much more a higher precip rate than full heads if the nozzles are the same. So let's say in this instance, this is 2 GPM for each nozzle. So quarter is 2 GPM, half is 2 GPM, full is 2 GPM. So the quarter is our smallest area. So the full 2 GPM go within that quarter area. But now on this, a half is double the area. So now evenly distributed between this full area is now each quadrant is now only receiving 1 gallon per minute per area. And now we move to the full, which is 4 times the area. So that 2 has to be divided by 4, which is 0.5 gallons per quadrant. And so that is why your fulls, if you have the same flow nozzle over different patterns, is that your fulls will be much drier compared to your quarters if they're on the same valve and run for the same amount of time, because each quadrant is now getting 4 times less than your single quarter quadrant. And another way to look at this too is, let's say on a rotor perspective, is the rotors turn at the same speed no matter what their arc angle is. They don't slow down or speed up. So let's say that rotor takes 1 minute to do this turn. So this is 1 minute to make this arc adjustment. So this is now going to take twice as long to come all the way around here. So that's 2 minutes. So what in this 2 minutes that it took to make its path, now this rotor has not only gone this way, but now has gone back. It's covered the same area twice, if that makes sense. So now in 2 minutes, it's gone this and this. So this quadrant has got 2 passes of water, where in 2 minutes, the quadrants have only received 1 pass of water. So again, here we go to the fulls. It's going to come around. And now it's going to take 4 minutes. 1 minute for this quadrant, 1 minute for this quadrant, 1 minute for this quadrant, and 1 minute for this quadrant. So it took 4 minutes to go all the way around. So in this one, in 4 minutes, it's then the rotor is going to turn back and cover this twice. So each quadrant gets the rotor passing over it twice, so twice as much water. And now this is 4 minutes, so now it's going to turn back. And now we'll turn back once more. So now it has 4 passes of water, so 4 times the amount. So this is how, because the rotor is moving at the same amount of speed, is covering 4 times the area on the fulls, 2 times the areas on the half, compared to the quarter. So how we make that up and match precipitation rate is that we use a 1 GPM for this instance for the quarter. Then we double it for half. So each quadrant is receiving the same amount of gallons per minute. So this is 2 GPM. And then to continue for each quadrant to be the same is then 4 GPM total would be your nozzle. So each quadrant receives 1 GPM. Now each per unit area is receiving the same volume of water. So now to do a demonstration of precipitation rate for this 25-foot by 25-foot area. And we're only concerned with the flow inside the box. So we have a full head, a quarter head, and a half head, 10 GPM nozzle, 8 GPM nozzle, 4 GPM nozzle, 3 GPM nozzle. And then this box is 25 foot by 25 foot. So if we measure 25 feet by 25 feet, it's going to be 625 feet. And then let's look at, so if this is 10, then the part shooting inside the box is going to be 5. Part shooting outside the box is going to be 5. I don't care what's shooting outside. 8. So it's going to be 2, 2, 2, and 2. And I don't care what's shooting outside, only inside. Then this quadrant's going to be 1, as all of each one is going to add up. And again, I don't care what's shooting outside. And then this is a 3 GPM. And this is a quarter and only shooting in, so that's 3 GPM. So then I have a 5, a 3, a 1, and a 2. So 5 plus 2 plus 1 plus 3 is 11 GPM. I'm going to multiply that by my 96.25. And then I'm going to divide that by my area, which was 625. And it gives me a inches per hour of 1.69. And so my precipitation rate for inside this landscape area is 1.69 inches per hour.